Hello learners, welcome. In the previous session, we have discussed about extraction process of aggregates, environmental impacts and mitigation measures. In this session, we are going to discuss about reclamation, embodied energy and other sustainable materials used as aggregates. Reclamation is the process of restoring mined out land to a natural or economically usable state. Reclamation process will ensure return of sustainable ecosystem of degraded land. The planning for reclamation occurs prior to start of mining operation. Reclamation may be implemented using 4 strategies. One is progressive, segmental, interim and post mining. Progressive reclamation will be done immediately after the removal of aggregate. Some place it will be difficult to implement because there is a possibility for the mix of mined out materials with the newly rejuvenated soil. Segmental reclamation follows the removal of mineral in designated location of the mine. This method is cost efficient and works better in homogeneous deposits. In interim reclamation process, the disturbed area will be stabilized with fast growing grasses and after some time final reclamation plan will be implemented. Post mining reclamation does not begin until the entire mine has been exhausted. A longer revegetation time is required for this. Let us see some of the examples. In Canada, 50 acres of an exhausted limestone quarry reclaimed as a premier botanical garden, which is one of the National Historic Site of Canada called Butchert Garden in British Columbia. Quarry Cove on the Oregon coast, USA is a quarry that was converted into a man-made tidal zone which is sustained by wave action. The another example is a mined out sand and gravel pit along the South Platte River in Littleton, Colorado was reclaimed as natural wildlife area. This park is one of the largest wildlife park within the city limit in the USA. Let us discuss about energy consumption by aggregate production. Energy is required to produce the aggregate. The energy consumed by the process to bring aggregate to a useful state is called embodied energy. It means the energy used in production and transportation of materials to site is called embodied energy. For each and every activity of aggregate extraction process, the energy is required. For example, to prepare the site for the operation, which involves removing vegetation and soil, establishing the processing unit, etc. To drill and blast these stones and to excavate the material, we need energy. To transport the material from the excavation site to the processing unit by truck or conveyors. Similarly, to process including multiple stages of crushing, screening, dust collection, segregation and washing, we need energy. This table shows embodied energy values for a number of common building materials including aggregates. In this table, embodied energy for some common building materials are shown. For aggregate, it is 11.11 kilowatt hour per ton. For the sand, it is 27.78 kilowatt hour per ton. Similarly, if you see crushed stones, 16.67 kilowatt hour per ton. For asphalt paving, it is 55.56 kilowatt hour per ton. In practice, energy consumption varies from one aggregate operation to the next. The embodied energy for the various aggregate operations had been calculated, which ranging from 6 to 139 kilowatt hour per ton. Actual consumption of energy is dependent on a number of factors including size of the plant, the type of the rock, the amount of drilling and blasting required, the method of process, the types of equipment used and its efficiency, maintenance of equipment and the skill of the workers, and also the mode of the transport. Methods to reduce the embodied energy in aggregate production includes efficient plant design, proper drilling and blasting to create appropriate sized material, selecting the right equipment and operating the equipment properly, properly maintaining the equipment, reducing ideal time of trucks, maintaining the haul roads, and be giving a proper education and awareness among the workers. Because of these measures, the release of greenhouse gases to the atmosphere can be reduced appreciably. Best management practices are required to limit the environmental impacts from aggregate mining. The handbooks and guidelines are published by various organizations including government agencies and industrial associations for the best management practices. Let us discuss about other sustainable materials used as aggregates. Shells, calci and clinkers can be used as aggregates in low specification applications. Some manufactured products can be used as substitute for aggregates. Slag is a byproduct of iron and steel refining. This can be used as aggregate. Perlite, vermiculite and shale can be expanded by heating, and that can be used as a lightweight aggregate. Sometimes other materials are used as substitutes for aggregate in concrete and asphalt products, which are designed for special applications. Shred rubber tires are used in asphalt to reduce the noise. Broken glass or cullet are used in aggregate base courses. Coconut shells are used as aggregate. Burned coal cinders are used in cinder blocks. We can discuss about recycling of aggregates. Large quantities of concrete waste are generated from demolition of roads and buildings. Most waste are disposed in the low level area. This low level area is acting as a funnel. During the rainy season, it collects the water and recharges the aquifer. The dumping of waste in low level area affects the system. Asphalt pavement and cement concrete can be recycled, which will reduce the space in landfills and also reduce the amount of natural aggregate needed to be mined. Reinforced concrete contains reinforcing steel bars, which require magnetic separation. Recycled aggregate also contains cement paste, which has different properties from aggregate. Recycled aggregate may be used in low specification applications, or it can be used along with fresh aggregate. Let us discuss about the lightweight aggregate. Lightweight aggregate is aggregate having a relative lower density than normal aggregate. Naturally occurring lightweight aggregate is pumice. Most lightweight aggregate is produced from materials such as clay, shale or slate. Perlite, vermiculite and shale can be used as aggregate. To produce lightweight aggregate, the raw material is expanded to about twice the original volume of the raw material by heating. The expanded material has properties similar to natural aggregate, but the density of this aggregate is less. During the production of lightweight aggregate, the mined out raw materials will be crushed with the crusher and screened. Oversized material will be returned to the crushers. The materials that process through the screens will be sent to the rotary kiln, where it will be fired with coal, coke, natural gas or fossil fuel to the temperature of about 1200 degrees Celsius. This process will expand the material. During this process, volatile organic compounds will be released. From the kiln, the expanded product will be transferred by conveyor into the clinker cooler, where it is cooled by air and forming a porous material. After cooling, the lightweight aggregate will be screened for size, crushed if necessary. This figure shows the manufacturing process of lightweight aggregate. Let us discuss about the emission and its controls during the production of lightweight aggregate. The production of lightweight aggregate process emits sulfur oxides, nitrogen oxides, carbon monoxide, carbon dioxide and volatile organic compounds. Chromium, lead and chlorides are also emitted from the kilns. In addition, other metals including aluminum, copper, manganese, vanadium and zinc are emitted by the kilns. In addition to this, clinker cooler emits carbon dioxide and volatile organic compounds. Using this lightweight aggregate, the lightweight concrete can be produced. Because of lightweight concrete, the weight of the actual structure is reduced by 20%. This will allow structures to construct larger for the same foundation size and for the same carbon footprint. Dear learners, so far we have discussed about reclamation process and its strategies, energy consumption by the aggregate production and other sustainable materials which substitutes aggregate. In the next session, we will be discussing about sustainability of cement. Stay tuned. Thank you.